Hello, everyone. So let us continue with that point that I left in the previous video. So where I tried to talk to you about the average degree of polymerization. So degree of polymerization, if you remember from our previous discussions, you know that degree of polymerization is nothing but the number of repeating units in a polymer. So when I talk about the average degree of polymerization, it talks about in general the average number of repeating units that are present totally throughout a polymer matrix. So that is usually given by, if we talk about the average degree of polymerization, it is given by N0 upon M, where N0 is nothing but equal to the total number of monomer molecule present initially, and N is given by the number of molecules that have reacted, okay. So that when we do, we will get the value for the degree of polymerization. So let us look into first the step growth polymerization. So I have here, so let us see whether it's working or not. So here you can see we have bifunctional molecules shown in blue and red, okay, and there are 12 monomer molecules in this particular diagram, okay, 12 monomer molecules. Suppose I talk about the random, when we talk about the step growth polymerization, it is basically random union of the random reaction of the monomer molecule, a random reaction of the monomer. So randomly, two monomer molecule, two monomer molecule, two monomer molecule reacted, okay, from different parts of the reaction mixture. So total, how many monomers have reacted? 1, 2, 3, 4, 5, 6. Okay, so that means 50% of the reaction has happened. So when 50% of the reaction has happened, so this green dotted lines has now been replaced by solid lines. So that means reaction has happened. So once 6 molecules have reacted, so that means 50% of the reaction has completed. Now let us look at how many molecules are now present in the reaction mixture. So you have 1 molecule here, 2, 3, 4, 5, 6, 7, 8, 9. So there are total 9 molecules now present after the 50% of reaction. So how we calculate? We calculate the total number of monomer molecules present initially divided by the number of molecules present in the reaction mixture. So when we do it, we will get the average degree of polymerization to be 1.3. Okay. Now, further the reaction happens so that we combine two more monomer molecules here. So let us see how many unreacted monomers are left behind. So this is unreacted, this is unreacted, and this is unreacted. So total 3 unreacted molecules are present. So how many monomers have reacted? Total 9 monomers have already reacted. So 9 divided by 12, when you do, it is approximately 75% of the reaction has already happened. So when 75% of the reaction happened, so I have replaced the green lines by the solid lines. So that means reaction has happened. Now let us check how many molecules are left behind. So 1, 2, 3, 4, 5, 6, and 7. So there are 7 reactant molecules present in the reaction mixture. So degree of polymerization is equal to 12, that is the initial number of monomer molecules, divided by 7, the current number of molecules. That comes out to be 1.7. So this is after 75% of the reaction has been completed. Now, if suppose we react the rest of the monomer molecules that are present, when that happens, and then we calculate after 100% of the reaction, now the number of molecule, we calculate 1, then 2, then 3, then 4. Okay, and we calculate the degree of polymerization, it is 3. So after 100% of the reaction, the degree of polymerization is value is 3. Okay, so now you know how to calculate the degree of polymerization. So this is about the step growth polymerization. So right now, what I have shown here is basically the degree calculation of average degree of polymerization for a step growth polymerization. Okay, so right now I have talked about the step growth polymerization. Now, what I would like you to do is do this, start with the initial 12 monomer molecule. Okay, now try to calculate the average degree of polymerization for a chain growth polymer. So now what is the difference in the step growth and the chain growth polymer? That is what you have to see here. So here in step growth, it was random. Okay, so in chain growth, if suppose I activate this particular monomer, when I say 50% of the molecule has reacted, that means the second stage, first step of reaction is 50% of the reaction has reacted. So that means I have to react approximately 1, 2, 3, 4, 5, 6. So 6 monomer has to react. So if suppose this monomer is reacted, so is activated, so that means all these 6 monomers are going to link together in a chained fashion. So when the 50% of the reaction happen, so what happens? You have something like this. You have bonding here. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So here 6 molecules have reacted. Okay. So if we calculate the number of molecules present in the reaction, we have 1. Okay, and then these rest of the 6 remaining unreacted. Don't consider these lines. This is for the step growth, so do not consider. So how many reactions molecules are now present in the reaction? 6 unreacted monomer plus 1, so total 7. So 12 divided by 7. So after 50% of the reaction, degree of polymerization for a chain growth is basically 1.7, which is higher than that for the step growth polymerization. So in the similar manner, continue after 75% of the reaction, what is the degree of polymerization? After 100%, what is the degree of polymerization? So try to react further so that after 75, so calculate how many monomers should react to give you the 75%. So accordingly, react with these, react the number of monomers, and then calculate the monomer molecules in the reaction mixture, divided from 12, and then you'll get the average degree of polymerization. And let us compare what is the value of the average degree of polymerization of the step growth polymerization versus the chain growth polymerization. You will find that the value for the chain growth polymerization, the average degree of polymerization for a chain growth polymerization is very, very high. Okay, and that is why whenever you do the polymerization process, the average number of units that are linked more in the case of chain growth polymerization. So most of the polymerization processes that you find are basically done via chain growth polymerization mechanism. Okay, so I hope you understood this. So have a nice day with this particular understanding. Thank you very much.